First off, I'd like to tell you a little bit about myself. My name is Hunter Warren. I started this research last year and ended last semester with studying. On the left, you can see me, and on the right, there's a 5-gallon bucket. This is one of the means of feeding the worms vegetable waste from the Gardner-Webb. So, what is vermicomposting? Well, this is, of course, the reason why sampling of the worms, studying that is so important. This way, more quantitative evidence can be out for this vermicomposting to help college campuses. The means of composting that campuses use is thermophilic composting. This kind of composting uses bacteria, which they require the heat from piling on the waste a little bit and a little bit on top of each other. Of course, there are hazards of the seed building up too much with thermophilic composting, whereas vermicomposting, you're not going to have that issue, and it's a lot more manageable, self-sustaining. Some benefits for campuses, if they were to use vermicomposting, is that they would have less expense for the waste management, not having to spend so much getting rid of their waste from, say, the cafeteria. It would be a self-sustaining waste flow. So instead of things going to waste, such as the vegetable waste, it could be reused for something much more useful for the campus, which is a no-cost, nutrient-rich fertilizer. This could be used for the flower gardens and so forth around campus. And of course, there are also additional educational opportunities So the purpose of my research was to continue what had already been started with the rates of conversion with vermicomposting. But in addition to that, I seek to figure out a sampling methodology or methodologies to estimate the population of these vermicultures. So, as you can see here, the black lines representing when the worms were fed, blue lines showing the percentage of what of that last few worms actually ate to nutrient-rich fertilizer. In the summer months, as you can see, it's not too long after they're feeding that a lot of the vegetable waste is converted to fertilizer. Getting into the fall, it slows down just a little bit. As you can see, going from somewhere in September over to the end of September, there's not too much that is converted. And then getting into the winter months, as we go further into fall, the rates of conversion is slowed significantly. So with my research, 3 different means of sampling were explored. There's VIE, there's the by hand sampling, and then the bright light sampling, all of which I'll go into detail here. The visual implant elastomer, or the VIE, this was an attempt to do a marking recapture method, which is basically capturing a small sample of the population, releasing them, and then going back later to have another captured set of the population, see how many of them are marked, see how many are not marked, and estimate the population via a calculation from there. The problem with worms, though, is that they're small and they're slimy. It's not going to be too much that they really retain. So the VIE, as I thought, was going to be the answer to this in trying to do marking recapture. VIE, as you can see right there with the circle, lights up basically whenever exposed to a black light, making the worms that are marked very easy to see. And of course, with the recapturing methods, random plots of a vermiculture will be had about 1 liter throughout the vermi bed. And of course, the marked and the non-marked will be. Again, another image of the worms being marked. This had to be injected directly under the dermis of the worms. Here you can see me injecting the worms under a dissection microscope, and the circles showing where these worms have already been marked, just a tad bit. As the numbers show, the black line representing the amount of worms that were marked, and on the right side of the y-axis, this shows how much of, say, those that were recaptured were found, and how many, I guess, bits not attached to worms were found. Now, starting in March, it wasn't until a little less than a month later that any worms were actually recaptured from the small population that was being tested for retention. Just a week after that, these fluorescent dots started to be found, meaning that not all the worms were really retaining this marking, and this probably showing that this was not a viable means of sampling. So, I had to go through different means of sampling. This was by hand sampling, and this way, the food for the worms would be cast to one side of the vermi bed, as you can see in the left image. Worms would go over there, and they'd come together with feeding, come together with mating, and the sampler would basically just sift their hands through and get the clumps of worms, put them in the worm sifter, as you can see in the right image, and separate them from the matrix, and then weigh them. The mass of the worms, as some research suggests, is much more accurate in estimating the conversion rates of vegetable waste given to the worms, rather than just the sole number of the worms. This graph, sampler 1, sampling one vermi bed, sampler 2, sampling a different vermi bed. And just from a naked eye observation, it was estimated that the vermi beds would have roughly the same amount of worms, but not as much as more than a 50% difference. As you can see, it's what I got with this means of sampling. This was shown, of course, to have some viability to it, but a few different things that might change with later sampling would be perhaps having the same sampler doing the sampling, and of course having it all done the same day with this. So one more method of sampling which I utilized was, of course, the bright light sampling. Worms do not like light. They will burrow under the ground just to get away from it. So taking advantage of this, a light apparatus, as you can see on the image to the far right, LED light will be set up. Worms taken from the vermi bed would be amassed in the and as I soft away at the matrix, the worms would burrow deeper and deeper until they finally got to the bottom, and supposedly dropping into the bucket, separating themselves from the matrix in order to be counted. The only problem with this means of sampling that was present was that when they got to the bottom of the swarm sifter, they would kind of just dangle there, not exactly being perceiving that they were not able to go any further. And so I suggest that perhaps maybe a platform of some sorts be put under there just to help them or just to encourage them to go deeper and into the bucket, therefore separating themselves. So then the population could be estimated counting worms. There are a few things, of course, that I would suggest with further research of the worm sampling. The last two means of sampling, which I mentioned, the by hand and the bright light sampling, appear to be the most viable options of the three. And of course, the further development of the vermicomposting initiative, especially with my campus, Gardner-Webb, would be great to see, in seeing this self-managing waste flow, less waste being created, and more benefit coming from food. For some acknowledgements. And I would ask you just to ask questions down below in the comments if possible. And here are my references.